Today we're going to make the triple switch box or the double switch box for the WeShare solar suitcase. I'll show you both switches, but we will actually wire the double switch today. To do this, you will need a box, a switch box that is appropriately sized for the switch. You will also need a couple of cord grips that screw into the box that hold the cable. And you will need a pigtail. This one's designed with the expansion plug on it so that you can plug this into the solar suitcase. This part goes into the solar suitcase. This part goes into the switch box. You'll need a couple of lamp cords with bulbs, 12 volt DC. And you will need a terminal block. And what we supply you with is a Wago connector. If you're doing a triple switch box, you need a 5-position block. Since we're doing a double switch box today, we just have the 3-position block here. So the tools that you will want for this project are a utility knife if you need to cut the cable, a wire strippers and cutters, a 6-in-1 screwdriver so you'll have both Phillips and slotted tips, a pliers for attaching the cord grip, and possibly a needle nose pliers to help you when you put the wires around the terminals on the switch. You may want a soldering iron for soldering the wire to make it solid, the part that goes around the switch. And finally, a digital multimeter that has a continuity testing function. So first we need to prepare the box for assembly. And many boxes actually have these knockouts here that are not knocked out. That way the box will stay sealed unless you need to put a hole in it. So for our purposes, we'll need to knock out this piece of plastic and this piece of plastic here, one on the top and one on the bottom. And to do this, all we need is a hammer and a large screwdriver, and we need to put on our safety glasses. I'll just go do this and I'll be back in a second. I'm wearing safety glasses. I put the big screwdriver against the plastic, it gets knocked out, and I give it a good firm tap with the hammer. And you can see they made a nice hole here. And then I'll flip it over and I'll do the same thing on the other side.
Action.
Okay. So now we're going to put the cord grips into the electrical box. And the way we do this is first we remove the nut. And we choose the side of the cord grip that has got the coarse threads. The fine threaded side is actually for squeezing down on the wire after we put the wire into the box. So I'm just going to screw this into the box, and I need to go ahead and make this good and snug now before we put in the wires. It's okay that this came off. So we put this on, and then we use a pliers, and we get it good and tight. And you can see the gasket is actually squeezing into the box, so it's a good waterproof connection. And then I'll do the other one. And now we're in good shape and we're ready to go prepare our wires. In this step, what we're going to do is we're going to push the wires through the cord grips and into the box. Then we're going to strip off some negative wire and connect them all on this Wago connector here. So we'll bond all of our negatives together. So I'm going to use both sides of the box. So I'm going to put the 2 lights on the top. So I'm going to push them in, and now I've got this extra thing to push in here, but I may need to bend it a little bit so it goes through easily. I'll push it through. You can see it actually goes through really nicely. So one is in. Second one will probably be a little more challenging because there's less space. So I'll push that through. Oh, not bad. And we want to push this cable housing all the way into where we can see it on the inside of the box, just starting to peek out. So as you can see how the cable housing is starting to show here, right there. And then we clamp this down good and tight. This holds the cables so that the wire cannot be pulled in or out. So if somebody pulls on the wire, it will not mess with our connections. and it also keeps out insects because it seals around the cable. So you can see it's tight enough when you can pull on it and the cable doesn't move. So these are ready for wiring, and now I'll put the pigtail in on the other side. And I can see the cable now, so this is when I will tighten it down. Get it good and tight. And you may be able to do this with your hand tightness, and you pull on it to make sure it's really in there. And now I've got all the wires I need for wiring the switch. And that's the negative coming in from the expansion port. And then the other two are white wires. And we're going to go ahead and again strip off about 3/4 of an inch. This one. And this one. Give them a twist. Now we're going to insert them into the connector. Push it all the way in so that you don't see anything but insulation. See how that's in there? Put in the lever, and that's in there nice. Put in the second one. Drop the lever, and finally we'll put in the third one. And what's nice is you're going to get all your negatives together, and you can push this connector and the negatives to the bottom of the box, and you'll have room now to work with your positive conductors. So I'm just going to push this down in the bottom, get it out of the way, and now I've got my 3 positive wires left. This is the wire, the red wire from the expansion port is what's going to feed the switch, and these 2 black wires are what are going to go to each individual light. Let me show you the switch. It's a little bit confusing because it's meant to be able to do a couple different things. These black screws with this tab connecting them to each other is for the power coming in. Leave the tab alone. All you have to do is put power in one screw and it'll feed both positions. And then when you turn the switch on, it'll transfer power over to these 2 screws. So this is the power in, is on this screw right here. So I loop the wire in the direction that the screw turns. So the wire goes around the screw this way. I use either my needle nose or I can use my wire stripper to pinch the wire around the screw. See how that kind of goes around the screw there, and that'll keep it on even better. And then I screw it good and tight. Okay, and you can see that this is really compressing on the copper wire, giving us a really good tight connection. Remember, we don't want this to never fall apart out in the field, so we really give it a good crank. Not superhuman strength, but quite tight. And on the other side, we connect the 2 positive wires that are going to the lamps. Again, it goes around the screw in the direction of the turn. Hold the wire in place. Pinch it shut with your needle nose. I'm going to grab this one since it's easier for me to use. There we go. And I'm going to go ahead and screw down on this. Okay, so now you see that the 2 positives going to the lamp are complete and they're tight. It's these 2 screws here. And this is the power in, and it's nice and tight. And our negatives are already attached and connected. And so this is a really good time now to do your QC to make sure that everything's properly wired before you screw the switch down into the box. So let me show you how this is done. So now we're going to test the switch to make sure it's properly wired by using the continuity function on the multimeter. So I'm going to put it to continuity. And we're going to start with the positive on the expansion port plug. So I'm going to stick 1 probe inside here, making contact with the positive side of this plug. And then I'm going to first make sure that there's continuity between the plug and the input side of the switch. And you can see that there is. And now with the switches turned off, I'm going to see that there's continuity to the other side of the switch. There shouldn't be, because the switch should break that connection. And you can see there's no sound. Now I'll turn the switches on, and we should hear a sound. Get a sound here, so that means this switch is working. But it shouldn't turn on this side, see? It doesn't turn this side on. But now when I turn this switch on, it will also show continuity. So this tells me the switch is properly wired. And now I'll make sure that it makes it all the way to the light sockets. So on the bottom of the light socket there's a contact place. It tends to be the more coppery of the two pieces of metal. And you can hear I've got contact here, and I've got continuity here. So that's good. Now to make sure that there's not a possibility of a short circuit, I'll also take my probe and touch it to the edge of the socket on the lighter piece of metal, which is to make the negative side of the connection. I should have no beep and no continuity, because if we did, that would mean there would be some kind of a short circuit in the system. So there's no beep there, and now I'll just check the plug just for good measure to make sure there's no connection between plus and minus, and there isn't. So this switch box checks out really nicely. I'll turn off my meter. I'll make sure my connections are good and tight. And then it's time to screw it down. Now sadly on these boxes the screws are really hard to turn in here, and kids often will strip them out. So really show them how to properly use a screwdriver and really bear down on it and make sure the screwdriver doesn't slip through the screw, which can injure the screw or damage the screw head. It's not the end of the world if they do that, but if they do it carefully, they'll have a very nice connection. And now for the finishing touch, we will add the cover plate. It's got a screw in the middle. You put it down here, use your slotted screwdriver. And we're good to go. Now to energize the switch box, all you need to do is screw in your light bulbs and plug it into the expansion port, and you can fire it up because you've already tested it. If the light doesn't come on, it either means there's a loose connection, or sometimes on these sockets the metal tab on the bottom that's supposed to contact the bottom of the bulb is not quite bent up high enough. So if you find that there is a problem with the system turned off and disconnected, you can pull that tab up. And that's good. We're done.